Hi, Greg Taylor here, talking about Category 1 and Category 1 fan-assisted appliance vent systems. Always a good idea to review the categories of appliances before we start doing any vent sizing or vent system applications. If you're in Ontario, our codebook indicates right in the definitions, front of definitions, the appliance categories. Page 24 is where you'll find them in the B149.1-20. A Category 1 is a natural draft appliance, less than 83% efficiency, which, as an example, would be a standard efficiency natural draft furnace or a standard efficiency natural draft water heater, would also fall into that category. You can see here I've got a natural draft water heater, natural draft standard efficiency furnace on the left-hand side of the diagram. I also have a mid-efficiency furnace there that is going up into a metallic B-vent system or possibly a chimney liner, depending on the application, which I'll talk about in a little bit. A Category 2 appliance is a natural draft appliance above 83% efficiency. There are no approved appliances currently in this category. Now, there could be, just very, very unpopular, not really a big reason or a big push to have anything in this category. So really, for our purposes, Category 2 is really defunct. You can have it happen. I've seen it. Actually, natural draft pieces of equipment over 83% efficiency, but they're generally very unsafe to be utilized unless they're supervised pieces of equipment. Category 3 is going to have a positive draft fan-assisted appliance below 83% efficiency, a regular old power-vented water heater that's sidewall vented, or a mid-efficiency furnace that's sidewall vented would fall into a Category 3. A Category 4 is going to be a positive draft fan-assisted appliance, 83% efficiency and above. A high-efficiency condensing furnace would fall into Category 4 as an example. You can see the power-vented water heater here on the left. Again, sidewall vented using 636 vent pipe, and the high-efficiency direct vent or sealed combustion high-efficiency furnace on the right. Again, using that 636 venting material to direct vent out the sidewall of the house. Keep in mind, we do not use these tables for positive draft vent systems. So categories 3 and 4, those you're going to refer to the appliance manufacturer's installation instructions. Up until recently, we haven't seen where too many of these pieces of equipment, they don't co-vent together when they're Category 3 or Category 4. They typically have their own independent venting system. We're starting to see now where certain manufacturers have gotten approvals to be able to co-vent or multiple appliance using one venting system in Category 3, Category 4. Navian water heaters are an example of what we're starting to see now, where they have a manifold type of venting system that has been approved with a type of 636 for that application. So in days past, we used to say that there was nothing out there that was available. Now we're starting to see certain manufacturers get approvals to do it. We talked about Category 2 has no appliances currently certified. So really, everything we're going to talk about today is going to be for Category 1 appliances, and we're going to have a little bit of a wrinkle, which we're going to talk about. Yeah, here's a wrinkle. A mid-efficiency furnace that has a fan to assist in the flue products through the heat exchanger. If we connect that mid-efficiency furnace to a B vent or double wall vent or a C vent, single wall vent, and then into a chimney or out through the B vent, basically through the construction of the house. So the perfect example here would be where we're removing an old standard efficiency piece of equipment and we're installing a mid-efficiency in its place. Now, in Canada, mid-efficiencies really haven't been around now for quite a few years. Our government didn't like the efficiency of the mid-efficiency furnace and took it out of the market. So really, all we have in the way of options now typically are going to be high-efficiency pieces of equipment when it comes to normal furnaces. They still make mid-efficiency like garage heaters and rooftop units, but when it comes to actual furnaces themselves, the choice really here in Canada for about the last 10 years has been a high-efficiency furnace only. But back in the day, we used to put mid-efficiency furnaces in, and we would take out a standard efficiency natural draft furnace and replace it with a mid-efficiency furnace. Now, when I first started in the trade many, many years ago, my hair wasn't as thin and gray, We used to actually have sidewall venting where mid-efficiency furnaces used a special type of plastic that could be sidewall vented. And I know the company I worked for at the time, we put an awful lot of these pieces of equipment in using the specialized plastic sidewall venting. What they found is that the actual venting system started to fall apart and erode mainly at the joints where they would just basically fall apart. So it was decided very quickly into the tenure of this sidewall venting of mid-efficiency furnaces that they would discontinue that type of a vent system for the mid-efficiency furnace. But if a customer still had a B vent from the old appliance, let's say, or had a chimney, we could line that chimney and actually hook up the mid-efficiency furnace to exhaust either through the chimney or through the B vent at that point. So when we actually have a mid-efficiency furnace that uses the old natural draft B vent or the natural draft chimney, usually with a chimney liner in it, we will actually have at that point the option of putting that mid-efficiency in. We obviously are not going to sidewall vent this mid due to the facts of what I just talked about. So if we have a mid-efficiency that goes into a B vent or into a chimney, we can actually use these tables for that application as well. There is a mid-efficiency furnace, again with a metallic vent on it, so chances are it's probably going into either a line chimney or existing B vent system, typically that would be installed in the house. Now, they didn't get rid of the sidewall vent application entirely. A lot of your manufacturers came out to say that if you used a certain type of stainless steel for your venting application, you could actually still sidewall vent the mid-efficiency furnace using that stainless steel type of application. Best advice to give you would be, if you ran into a situation like that, talk to your manufacturer of your equipment and see what they suggest you use in the way of a venting system. The vent system components in a B vent system basically are going to be the base support and the fire stop spacer, or the two that I've got listed here. The base support will be at the lowest point of the venting system, and that's actually the piece that screws into the wooden joists, floor joists around it to support the weight of the entire venting system. So a little harder to see, but right at the top of the ring, so to speak, or right at the top of the hoop on that base support, there's actually a nut and a bolt. The idea being is that the B vent actually slides through, and then we tighten up or cinch that B vent to hold that B vent in place, so that when we move the appliance out from below it, the whole venting system doesn't drop. That cinch bolt nut will hold that B vent in place. The fire stop spacer doesn't attach to the B vent. The B vent comes up through the middle of it, but you see the 4 ears that are attached on the fire stop spacer, and as the name indicates, what that does is keeps the combustible materials an inch back. That's why those ears are placed where they are on the system, to keep all the combustible materials the required 1 inch away from the double wall or B vent. They mean the same thing. I call it B vent all the time, but what I mean there is double wall vent according to the code. Other components you're going to see are a single wall to double wall vent adapter and a double wall vent elbow. Again, double wall being B vent. The trade name out there a lot of times is going to be B vent. The roof cone or the flashing, that's the part that attaches to the roof. And I've got a picture showing you coming up here. The storm collar slides down very, very tightly around the outside surface of the B vent. The idea being any rain or moisture that starts to drip down the outside surface of the vent it actually hits the storm collar and deflects it away so it doesn't come inside the building. The actual B vent pipe itself, or double wall vent pipe, a rain cap. You can see there we also have a single wall elbow, also known as C vent, an actual piece of pipe there, and what we call a vent increaser, which takes that single wall vent or C vent from one size to another to adapt the different sizes. So you can see on this garage heater that I put in, we've got a 3-inch outlet off the garage heater, but we quickly moved to a 4-inch, and the actual B vent system is 4-inch all the way up through the roof itself. And you can see again, before the venting is hooked up, I basically took a picture of the actual base support with the B vent attached to it, holding it up into the ceiling. And then you can see after I put the heater up, the actual piping and everything attached to that, the venting itself. On the picture on the right, you can see there that we have the base support. We also have the B vent, the rain cap, and the storm collar components all listed or shown there on the side, the right-hand side picture of the system. A B vent or double wall vent cannot be cut or altered. The pipe is available in 6, 12, 18, 24, 60-inch sections most commonly. Sometimes you can get what they call an adjustable B vent length, which does have a little bit of I guess, flexibility in the length. There's sections that slide in and out to varying lengths. I commonly didn't use these in the field. We typically would make do with these pre-cut links or pre-manufactured links, I should say. These pipe sections twist lock together. They should never be screwed together. I see them screwed together all the time. Most of your manufacturers will indicate that they don't like to see screws in B vent. If you are going to use the screws, which I've seen some technicians do, use very small screws, half-inch screws, because you don't want to penetrate the inside pipe of the B vent. So this is just going to be used just to make sure that it locks together. B vent is always going to be utilized for the vertical vent section that extends from the location of the appliance to the outdoors. So basically, as it goes through the gull of the house, so to speak, or the sections of the house that are all covered in, that all should be B vent. The only place you should ever see single wall or C vent is going to be in the room where the appliance is located, and it needs to go over to double wall vent before it leaves the room itself. When you're going from B vent to single wall or C vent, or vice versa, it's usually going from C vent to B vent, you're going to use what they call a C vent to B vent adapter, and which of course is going to be a piece that you're going to purchase with your venting. Single wall or C vent, on the other hand, can be cut to length and must be screwed together. In the past, it was a code requirement to use 3 sheet metal screws to attach vent pipe and components together. No longer a code requirement, still a good practice to follow that practice and put those 3 screws at 120-degree intervals around the pipe. Make sure both the vent material and fittings is the required thickness for the application. Keep in mind, perimeter pipe is thinner than vent pipe. And I've seen where actually both your fittings and your pipe have been sold by wholesalers that have indicated that it's the correct stuff. And I've actually called out a few on that due to the fact that they were using 30 gauge elbows instead of the 28 gauge, which is required for appliance venting applications. So make sure that you're getting the correct material if you're putting this together as a vent system for carrying flue gas. C vent is often preferred to B vent, or single wall is often preferred to double wall. It's cheaper, easier to use, easier to alter. Depending on the appliance configuration, you may not be able to use single wall vent at all, as we're going to talk about as we move on in this presentation. So, as I call it, general venting requirements for dummies or technicians that do not know the finer points of vent sizing. So your GVRs are the rules of venting. Okay, everything in the book really comes down to GVRs. So on page 275 of your 2020 code book, you will be able to find the general venting requirements. The first thing that they take note of is the pink page directly across from page 275 indicates that Ontario has made the complete annex of vent sizing mandatory, meaning we must follow that to the letter for legal code compliance. The better you know the general venting requirements, the easier vent sizing will be. You can introduce the GVRs and then give some examples. 275, page 275, the code, we're going to start at the general C11. The tables provide a method for vent sizing a natural draft and fan assist in Category 1 appliances, or mid efficiencies that we're talking about a little earlier that go into venting systems. So those mids going into chimneys or existing B-vent systems would be what we're talking about here. C12, if any air exhausting devices share the same home as a natural draft appliance, the DP column shall be used to determine proper vent sizing of the system. So keep in mind, when you look at a TSSA fuel safety exam, they would have to tell you in that case that there are air exhausting appliances in that house to make you use the DP column. If there is no mention of air exhausting appliances, then you won't use the DP column. You'll use what we call the max column, okay? In the field, How often are you ever going to be in a building that doesn't have a single air exhausting appliance, meaning that it could be an electric clothes dryer, could be a gas clothes dryer, could be a central vacuum, it could be a bathroom exhaust fan, a kitchen exhaust fan. Anything that takes air from inside the house and basically has a mechanical purpose of getting it outside is really an air exhausting device. So in reality, C12 is going to be the column that we're going to use most frequently when we're out there in the field. Or C12, sorry, DP is going to be the one most commonly used out in the field. So these tables will be used for natural draft appliances and mid-efficiency furnaces using B-vent systems or B-vent or a C-vent with chimney applications. If the home has any exhaust fans or other appliances, obviously we're going to use the DP column, as we just mentioned, for calculating natural draft appliance vent sizes. Use these tables only for Category 1 natural draft or Category 1 fan assisted. They're to be used on vents and chimneys interior to the structure. All sides of the vent are running in warm areas of the house. An exterior chimney is defined as having one side or more exposed to the outdoor temperature below the roofline. So if you look at a chimney overall, your typical chimneys, real old houses have what they called interior chimneys. And looking at interior chimneys, that's where basically a chimney ran right up the middle of the house itself. So all four sides were surrounded by heated air, which really made the venting that much more effective because it didn't have that cold air hitting one of the surfaces of the chimney. Houses that were built mainly in the 1950s, 1960s, 1970s that had chimneys, in many cases they moved away from those chimneys that were in the central part of the house and came up through the middle, and they put them on one end or the other, in most cases, of the house. But by doing that, they're now exposing one or more sides of that chimney to the exterior environment. And what we really want to understand here is that really that is detrimental, that those exterior exposures of that chimney are really going to hinder how well that venting system works. But our code says if we drop a chimney liner down a chimney that has one or more sides exposed to the outdoor environment, it no longer sees that chimney as being an exterior chimney and allows that to be used for many different applications. So dropping, in fact, in codes previous to the one that we're currently on, they made it an option whether the technician would drop a liner in certain situations. But quite honestly, I've taught this for years, there were so few situations that didn't require a liner. But unfortunately, a lot of technicians, because they really didn't know how to size this effectively or what to do, they took that as being an out, meaning that they didn't have to drop a liner down the chimney itself. This particular code book indicates that we do have to drop a liner. I don't think it allows for any exceptions anymore, except dropping a liner in that application. Now, again, very rare I think you're going to get into these situations. I mean, the last time I dropped a liner, I'm trying to think of how many years ago it was. Because really now we're looking at Category 4 appliances that are mainly installed here in Canada in a lot of our applications. So we could be pulling out an old furnace, but typically we're not using that chimney to revent anything. We could have it still remaining for a natural draft Category 1 water heater, at which point we'd have to drop a liner. But again, it's becoming rare and rare that we're going to be performing this. If a B-vent or certified chimney lining system is installed in the masonry chimney, the code does not consider the vent system to be exposed to the outdoor environment, which is what I just said. If the vent connector size determined from these tables is smaller than the appliance draft hood, outlet, or flue collar, the smaller flue size may be used, provided that the total vent height is at least 10 feet in height. Vent connectors on draft hoods 12 inch and less cannot be reduced by more than one pipe size. Because keep in mind, when we get up basically about 10 inches, we're now going to have 2-inch increments in between sizes of pipes. There is no 11, there is no 13, there is no 15. What there is 10, 12, 14, 16, and so on. Now, below 10 inches, we typically are going to have 1-inch increments. Definitely below 8-inch, we'll have 1-inch increments. You can have 8, 7, 6, 5, 4, and 3. Usually 3 inches is about the smallest I think that you're ever going to see when it comes to actual B-vent or C-vent, single wall or double wall vent connector. Vent connectors about 12 inches diameter, cannot be reduced more than 2 pipe sizes. Really, that's something I guess to know if you're into big stuff, but for the most part, something that most of us won't really deal with that frequently. In the event that we're reducing that actual vent size, or that vent connector size, we have to reduce the capacity of the vent connector listed in the tables by 10% if we're doing that on a fan-assisted appliance. If the draft hood outlet on a natural draft appliance is 4-inch in diameter, it cannot be connected to a 3-inch vent connector. Now, not true for a fan-assisted appliance. Piles of fan-assisted appliance, like a mid-efficiency furnace, had a 3-inch fan outlet. And if that was the case, you were allowed to increase up to 4-inch. If it's a natural draft, though, that draft hood has to have a 3-inch draft hood on it, or 3-inch draft hood outlet, in order to connect to a 3-inch venting system. Single appliance venting connection. So C24 single appliance venting configuration with 0 lateral links is assumed to have no elbows. So table C1 and C2 will actually have a spot on them for what they call 0 lateral links. And we'll talk a little bit about those before. But all other tables, we're going to talk about the tables coming up here. It's assumed there are 2 90-degree changes in flue direction that are already going to be calculated and figured in to the table values that we're going to talk about. If the vent connector for a natural draft appliance has any additional 90-degree turns above the 2 that we talked about, we're going to reduce or subtract 10% for each additional elbow from the capacity of the vent connector table value. And again, I could read that to you 8 times and you might not understand it any better. The best way is to show you what I'm talking about. So we're going to work into some examples here. I'm going to show you that. If the vent connector for fan-assisted appliances has any additional 90-degree turns beyond the 2 that are allowable, 15% per additional elbow from the capacity of the vent connector table value is going to be derated by 15%. In all venting configurations, except what they call a manifold system, the 90-degree changes of flue gas direction are accepted as part of the vent connector, not the common vent. So we'll talk about that coming up as well. If the vent connectors are combined prior to entering the common vent capacity table must be reduced by 10%. Horizontal common vent length maximum is going to be 1.5 feet per every inch of vent connector diameter. And again, I'm going to talk you through examples on these, which I think will help your understanding much more of what's going on in these systems. If the common vent or vertical vent is offset, the maximum capacity listed in the common venting tables must be reduced by 20%, which is the equivalent of 2 90-degree elbows. The horizontal length of the offset must not exceed 1.5 feet for every inch of common vent diameter. And again, I'll talk more about that coming up as well. Try and clear up the air. For appliances with multiple input rates, or 2-stage appliances, for instance, the fan min has to be lower than the lowest BTU rating, and the fan max has to be higher than the high fire BTU rating of that appliance. So in a 2-stage piece of equipment, let's say that we've got 100,000 BTU high fire and we've got 60,000 BTU low fire. We've got to make sure that the fan min is going to be below 60,000. We got to make sure that the fan max is going to be above 100,000 or at 100,000 right on in order to make this situation work. And again, we'll look at those situations coming up here. Vent system sizing C29, a fan-assisted appliance may be common vented into an existing masonry chimney, provided the chimney is currently serving at least one draft hood equipped appliance, and the vent connectors and chimneys are sized in accordance with C7 and C8. Well, since this really has come into existence, now that they're saying that we're going to line everything, typically that's not something that we're going to do in table C7 and C8. So we'll talk much more about this as we go on. Single appliance venting of fan-assisted furnaces into a tile-lined masonry chimney shall not be done unless the chimney is lined with a B-vent or certified lining system. Well, again, now the code says that we got to put in a B-vent or a certified lining system at that point. And again, we're going to use table C1 or C2, which I'm going to show you coming up here, exactly how we're going to do that. So the certified lining systems will be sized according to table C1 or C2 for a single appliance, C3 or C4 for multiple appliance vent systems, When the certified lining system is used, you must reduce the common vent table diameter by 20% because the liner actually has corrugations in it, which creates greater resistance inside the chimney liner for the flue products to get out. So we definitely want to make sure that we keep that in mind. When we got a chimney liner, we have to reduce our common vent capacity by 20% off of our table values. If any additional offsets other than the two that are already accounted for in the equations or in the tables must have a common vent table value reduced by 10% for each additional 90-degree elbow. I'll talk a little bit more about that. If the vent height and vent connector rise and lateral are between table entries, linear interpolation shall be permitted for the calculation of permissible appliance input ratings. Extrapolation beyond the table entry shall not be acceptable. I will talk to you about interpolation and extrapolation because it is something that generally pops up on a TSSA exam, and I've had students in the past who have said, I had no idea what those two terms meant. So I want to kind of go through that when we get to that point and talk about that. When the vent table permits more than one diameter pipe be used for the vent connector or vent, the smallest permitted diameter shall always be preferred. So a little different than some of the other things that we've learned so far, which I'm going to talk about. So again, what I did was just basically shortened, if you will, the actual code clauses and made what I call the GVR cheat sheet. So again, using these for natural draft appliances and mid-efficiency furnaces using B-vent or chimney systems. If there's any air exhausting appliance in the house or the structure, as we call it, we're going to use the DP column when calculating natural draft appliance vent sizes. If a certified chimney lining system is installed in an exterior masonry chimney, the vent system is no longer considered to be an outdoor chimney and may be used to vent appliance exhaust systems. We talked about if the draft hood on the appliance, if the vent connector size is smaller than the draft hood, it can be used provided that the vent height is at least 10 feet. Again, those reductions, the appliance, if it's fan assisted, there's a 10% reduction of the table value for the vent connector. And as indicated, if the appliance outlet is 4-inch, we cannot use a 3-inch vent connector except for a fan-assisted appliance. So mid would be able to do that. All of the tables assume 2 90-degree changes of flue gas direction already calculated into the table values. The only ones that don't are C1 and C2 when we have what we call a zero lateral, which I'll talk about. Any additional offsets in the vent connector require an additional 10% reduction in the vent connector table capacity for natural draft appliances, an additional 15% in the vent connector capacity for fan-assisted appliances. You get 245s, that's going to be the same as 190-degree turn. I'll show you again coming up here when we get into the examples. If the vent connectors are combined prior to entering the common vent capacity must be reduced by 10%. If the common vent offsets, we're going to reduce the common vent table values by 20%. The offset shall not exceed 1.5 feet per inch of common vent diameter. Might be asking yourself some questions about common vent connectors. I'm going to go through all of that coming up as well. We talked about fan min and fan max, making sure our appliance inputs fit in between the fan min and fan max. Fan-assisted appliances cannot vent into a chimney unless a natural draft appliance is already co-vented into a chimney, and the chimney and vent connectors are sized using C7 or C8. As I mentioned, that basically is by the wayside now because code says that we've got a line and everything. So single appliance of a fan assisted into a masonry chimney not allowed unless it's lined, which of course it says now we have to do. If we're using a corrugated chimney liner, the common vent table capacity must be reduced by 20%. The common corrugated liner has any more offsets, we're going to reduce a further 10% for each offset. If the vent height and vent connector rise and lateral are between table entries, linear interpolation is permitted. Extrapolation beyond the table entries is not acceptable. And as we mentioned, if there's more than one size is permitted, we always want to go to the smaller size. It's always preferred. Before we get into the vent table layout, there might be quite a few that already shut this off because you thought, wow, this is going to be really complicated. Vent sizing really isn't complicated. The worst part I find about vent sizing is the fact that the vent itself, the rules that apply, what you have to do is keep all of these rules in back of mind on everything that you're doing in vent sizing. The math is not complicated. It's not complicated to do. It's making sure that you follow all of the rules which we just talked about. Okay, so let me walk you through some of those things coming up here, and we'll see. So there are going to be 8 tables in your code book, right? The first 4 tables, C1, 2, 3, and 4, are going to be used when we have an interior B vent system that's going to be used to exhaust the appliance flue products. So you can see the B vent sticking up there above the roof. The second 4 tables, C5, 6, 7, and 8, are going to be used when we have tile-lined chimneys to exhaust the appliance flue products. Now, we just talked about the fact that really, why do we even have these anymore? Because we're going to drop a liner in these things. There still will be instances when we get into larger applications where there isn't a requirement to have a liner. So I believe that's why these have remained in the code book and are still able to be used. And we're going to talk about some of those examples. As soon as we drop a chimney liner into a masonry and tile line chimney, it then, in the code's eyes, becomes like a B vent. So in other words, we're going to use tables C1, C2, C3, and C4 if we put a liner into a chimney. So either we're going to have a chimney, a B vent, or we're going to have a line chimney. So we're going to determine, are we going to use table C1 to C4 or C5 to C8? If it's a chimney with no liner, it's going to be C5 to C8. If it's a B vent or a line chimney, it's going to be C1 to C4. I put a little table in here, which I'm hoping will help when it comes to, you know, your kind of your choices here. Follow the arrows based on what you have in that situation. Do you have a double wall common vent? Well, I'll tell you, on B vent systems, you're always going to have your common vent going up through will always be double wall if it's a B vent system. It's whether do they have double wall vent connectors or B vent connectors or single wall or C vent connectors. They're very different because even though the diameter is the same between those two materials, double wall vent or B vent keeps much more heat in the venting system and exhausts much more of it on out through the double wall common vent to the outdoors. Some of the big disadvantages, as we talked about before, with double wall vent are expense. You can't cut it. Excuse me. You can't alter double wall common vents or B vents as easily. They're way more expensive and much harder to use. So the preference is always going to be single wall vent connectors. The other advantage to a single wall vent connector is it gives off a lot more heat. If you don't believe me, well, don't do this, but if you have a piece of equipment that's running and you put your hand around a single wall vent connector or a C vent, you're gonna leave your skin on that vent connector, depending on how hot the flue gas is. But if it's running for a little bit, you definitely will. It's a very, very hot process, and you'd have a hard time holding on to that. B vent, on the other hand, or double wall vent, is going to be it's just warm to the touch because we actually have an insulating quality of that B vent itself, which keeps the heat that is lost in that system at a lower level. So it's actually less efficient. We're taking more of that heat outside to be exhausted when we have a B vent system. So for those reasons, a lot of times we're going to see where single wall vent connector is going to be the preferred vent connector of choice in most applications. So you can see down there, if you follow the flow chart, for instance, if you've got your main exhaust stack as a B vent / chimney liner, my next piece that I see over on the left is double wall common vent, double wall vent connectors. Now, do you have one appliance connected to this vent system or two? Two or more, basically, is what it should say. So you can see there what table you're going to use, because right down at the bottom there, you can see I've got C1, C2, C3, C4, C5, C7, C6, and C8. And again, they don't follow an exact order because, again, what I've got listed above. So what you're also going to see, and it's the second one over, is going to be double wall common vents with single wall vent connectors. Again, 1 or 2 appliances. Let me just tell you that by far and away the most common one that we use out there is going to be table C4 in all of these applications. Now, if you get into tile line chimney, if you have double wall vent connectors going between the appliance and the chimney, you're going to use C5 and C7 based on whether you have one or two appliances. And then single wall vent connectors are going to be used, whether you got one or two appliances, and that's going to be C6 and C8 that will be used in that case. So we talked one or two or more appliances are one thing that we need to know. So table C1 and C2, only one appliance in the vent system. Usually going to have a B vent or a line chimney. Table C3 and C4 for two or more appliances, sharing the vent system again. Common vent, B vent, or a line chimney is most common. Okay, on this particular example, you can see by the diagram here, I have one appliance. It is completely double wall or B vent from the actual exhaust point of the appliance, or where the draft hood is located, all the way to the termination point above the roof line. You can see I've got them labeled there. If they're thicker lines, that usually means I've got double wall vent, common vent, and double wall vent connectors. You can see here, and if you start looking at the actual table itself, what you'll see is that the common vent and vent connector serving one appliance falls under table C1. You can see I've got a 23-foot vent height, which I have measured here. I've got a 3-foot lateral, natural draft water heater at 51,000, as indicated, double wall common vent and double wall vent connector. Okay, so now that we've seen that appliance, we're going to go to table C1. As mentioned, we really want to check the title, and that's why I highlighted the title here, because we have the capacity of type B double wall vents and type B double wall vent connectors serving a single category 1 appliance, which matches up with our diagram. So we want to make sure that the diagram is matching the table that we're using to catch the particular sizes. What you'll see is there'll be multiple pages a lot of times, a little bit of different information on each page. First of all, the first part of the table, right down at the left-hand side of the table, the columns going down, you're going to see it says height right out at the left-hand side. That height is going to be of the vent system. And by that vent system, what we're meaning is we're going to measure from the highest appliance in the vent system to the termination point on top of the roof. And that vent height is what we're going to use or choose on this table that we have. Now, you can see the vent heights that we have to choose here are 6 feet, 8 feet, 10 feet, 15 feet. The next table to this, or the one adjacent to it, will have 20 foot, 25 foot, 30 foot, 35 foot, and then I believe it goes, I believe it's 40 and might even be up to 50 feet. I can't remember on this particular table. What we're going to do, one of the big differences here in vent height, if we're in between table values, so let me tell you, let's say that we have a 14-foot vent height, okay? TSSA would have to tell you on a TSSA exam what your vent height system, or your system vent height will be. So they have to be able to kind of let you know what that vent height is in order for you to calculate appropriately the vent system sizing that we have here. But if you're at 14 feet, it would make sense so far in everything you've learned in the gas industry so far in your certifications that everyone would say we're going to 15 feet. Vent height is the opposite of what we do in everything else. In other words, if we're in between table values, instead of going to the next higher value, only in vent height, we're going to go to the lower table value. So even though we're 14 feet in the air and we're close to 15, we're going to go to 10 foot, not 15 foot. And I know a lot of you would be thinking, why do we do that? I'm going to explain that a little bit coming up here, okay? The next thing that we need to know is what is the lateral? How far offset is the appliance from the main vertical channel that we have to vent these products of combustion to the outdoors? So the lateral is going to be, again, a measurement in feet. And you can see in this table, they have a 0-foot lateral. There's only a 0-foot lateral in table C1 and C2. But let's pick in between values. Let's say that I have a 3-foot lateral, okay? And we talked about the fact that I'm going to the 10-foot vent height. So I'm down in the third column down, right? And I'm going to try and pick and see whether or not I've got the laser pointer here. So I'm at the 10-foot vent height that you can see. I want to come down, because I'm at 3 feet, I'm going out further, which is going to be a 5-foot lateral in this case. So whether I'm 3 foot, 4 foot, or 5 foot, I'm going to use the 5 foot lateral. If I'm 6 feet out, I'm going to the 10 foot lateral because that's what's next on the page. So I've got my vent height. Again, I'm in between table values. I'm going down in height. I'm going up in lateral. And now next to that, you can see I've got a 23 and a 57 in the next two columns. If we go right up to the top, you can see that we have the fan. In other words, this is for a fan-assisted appliance, like a mid-efficiency furnace. The minimum BTUs we would have going into that system would be 23,000. The maximum BTUs we'd have going into that system would be 57,000. You just have to know that these numbers don't have the 3 zeros on the end of them, but that's basically it's your BTU firing rate, or CFH as we like to call it sometimes, cubic feet per hour, which is really the 3 zeros missing off of these table values. Over in the next column, you'll see up at the top here, there's Nat Max and Nat DP. Remember, I just told you, if we don't have any air exhausting appliances in the building, we can use what we call Nat Max, or that column. Nat DP will be used if we have any air exhausting appliance in the building itself. People might say to me, because I did tell you, how often are you in a building without exhaust? But I will tell you, you get into some bigger residential types, and I'll give you an example. Let's say that we've got a 5-story apartment building, and it has a boiler room on the main floor that basically supplies the heat to the entire building. Well, that boiler room has an outdoor air supply coming right into that room. So because there's nothing exhausting air right from that room and it's bringing fresh air right from the outside, we can actually use the max column for that application. Now in a home, not so easy. Almost always we're going to use the DP column. So again, we've got the 10-foot vent height. We've got the 5-foot lateral that we talked about. We have a capacity. If we don't have any air exhausting appliances, we can put BTUs into the system of 40,000 BTUs. If we do have air exhausting appliances, we now have a new table value or capacity of 32,000 BTUs. Well, if I told you that we've got a 50,000 BTU water heater, right? Neither one of those fits. So what we're going to do is we're going to come over. Now, it's a 50,000 BTU natural draft water heater. So I'm not going to worry about the fan assist because this appliance isn't fan assisted. So I'm going to skip over here to these two, which is going to now give me a new capacity of 77,000 BTUs. Or in the case where we have a depressurization appliance, such as an exhaust fan, we're going to be looking at 62,000 BTUs. And if you look up at the top, those are all incorporated underneath the 4-inch diameter hood, or the 4-inch catchment here. So any of these four numbers, basically, when you go up to the top, are going to tell you that your vent connector size is going to be 4-inch. And so on as we keep going through these numbers. We pick the appropriate vent height, we pick the appropriate lateral, and then we move across and start sizing our vent connectors for that system. Now, with one appliance, we're going to have the same vent size from where the actual vent system begins and where it terminates. So in other words, it's all going to be the same size. We only have to do one calculation. This gets a little more complex a little further on because we're going to be calculating more than one appliance that's using a vent system. So we'll talk about that coming up. As I mentioned before, you can see this next table now has the 20-foot, 25-foot, and 30-foot vent heights. And again, the laterals are going to increase as we kind of go in this system. So you can see there as your vent height goes up, we're obviously going to pick the appropriate table. If we had a vent height, let's say at 28 feet, we're going to go to 25. If our lateral is 6 feet, we're going to the 10-foot lateral section right above my highlight there. And again, I'm telling you that we've got an appliance, let's say, that's going to be 94,000 BTUs, and there's no air exhausting appliance in there. We can get away here with a 96,000 BTU 4-inch vent connector for that appliance. If I said there is air exhausting appliance and we said it was 94,000, then obviously 87 will not work. We're going to have to move over here to the 5-inch, which now has a capacity of 147,000 BTUs for that application. So all we're worried about right now is going to be vent connector sizing. We're going to talk about other stuff further as we go. So the big thing here to realize when we look at vent height, and what I'm trying to show you here with this example is that actually, if we actually had two 4-inch vents, let's say, or two vents that are the same diameter coming down into a building and terminating at the same height, what you're going to see is we've got one vent, and we're just going to have to imagine here, one vent terminates 3 feet above the roof surface. The other vent terminates 300 feet above the roof surface. And you can see I've got my aircraft landing lights up top on the taller vent, and we got guy wires holding that thing up because, of course, the wind's going to knock it over. Everything else that we've learned, the longer the length, the greater the resistance. Venting is different. Vertical sections of venting like this. Now, I'm saying this in jest because in true fact, there is a point where this does not work. But for the purpose of our example here, the vent that terminates 3 feet above the roof is going to create a little bit of suction through that venting system because there's a pressure difference between where the flue gas enters closer to the Earth's surface and where it exhausts, which is going to be higher in the atmosphere. If we have a much longer vent system, which is much higher into the atmosphere, it almost sucks like a vacuum through that thing. In other words, the actual airflow going through that longer vent system is going to be much stronger. So the actual vent system, even though there's more material and more resistance in it, the suction is so great it overcomes and actually is a better vent system due to the fact that there's a greater distance. And because it's rising up higher in the atmosphere, there's more of a negative pressure the further away from Earth that we get, so the more a vacuum is going to be created. So this is why if we're in between table values, instead of going to the longer run, which we typically have done at everything from gas piping to different things that we've learned so far, venting height is always going to be going backwards, if you will. So if you're in between table values, if my vent system, I'm showing here a 23-foot vent system on the left-hand side, that 23-foot vent system, the table values are going to be 20 feet or 25 feet. We're going to go to 20 feet if we're going to use the table. A little earlier, I talked about interpolation and extrapolation. And again, I said I wanted to explain that. I'm going to do that now before I forget. Interpolation is going to be, so if I said on our vent table, it says that we can have a capacity, and again, I'm making up numbers here. At 20 feet, it might say we have a capacity of 40,000 BTUs. At 25 feet, again, making up a number, it could say that we have a capacity of 45,000 BTUs. So at 20, we had 40. At 25, we have 45. Well, again, doing the quick and simple math, if I were to go in and say, okay, well, I'm at 23 feet, so I can do the math. I'm a smart individual. At 25, I know I'm good for 45,000 BTUs. At 20 feet, I know I'm good for 40,000 BTUs. That means basically at 21 feet, I should be good for 41,000 BTUs. At 22, I should be good for 42,000. At 23 feet, which is what I have here, I should be able to calculate that I could actually get away with 43,000 BTUs. That is called interpolation. In other words, the table only gives you the two values at 20 and 25 feet, but you mathematically are able to calculate what it would be for every foot increment in between. Interpolation is allowed, okay? So in the real world, we could actually use interpolation to figure out exactly to our vent height what the actual input allowable would be. Extrapolation is going to be, let's say our table ends at a 50-foot vent height, for instance, and we have a 60-foot vent system, and we said, well, mathematically, we could go in and calculate the difference based on the table values that are already in the table. We could go ahead and calculate what 60 feet would be equivalent to. Because the table has ended, that is the outermost parameter is 50 feet. Extrapolation is known as basically going beyond the table values. And that is not allowed. So 60 feet, you would not be allowed to go ahead and mathematically calculate that mathematical equation for 60 feet because 50 feet is the limit of our table. So in between table values that are given is called interpolation. Anything outside of the table values that are given is called extrapolation, and that's not allowed. Interpolation is. So hopefully that clears up a little bit of interpolation and extrapolation. So again, vent height, we are going to go at that one differently, right? We're going to make sure at vent height that we're going down in vent height. Now lateral is going to be the other way. So you can see in this case, it looks like it's 3 feet on the lateral in both cases. So if we got a column that says 2 feet or 5 feet, now we're going out to 5 feet because more resistance is required, or we're going to have more resistance when we get longer in that table value. So now we're going back to the way that we've learned. Worst case scenario is always going to be a longer lateral length. Okay. So I know it's confusing. It's just something you got to put to memory. You just have to realize that because there definitely will be tests coming at you on both of those applications. So as I indicate here, like everything else, we're going to go to the worst case scenario. So the longer the vent height, the greater the vent sensitive functions. So again, we're going to go backwards at that point is really what we're trying to indicate. So on this application here that we have, what I should have done is taken that table value from before. But obviously we're looking at something that is in between 20 and 25 feet. So we're going to say, let's say 23 feet. And again, if we had a 3-foot lateral, we're down at the 5-foot section, and you can see we have a 5-foot lateral there. At the 20-foot vent height, we're on the correct table. Table C1, one appliance that has double wall vent connectors all the way. And when we look at the BTU rating on that appliance before, I apologize, I should have stopped there, but I didn't. Obviously, we're looking at the fact that capacity of 96,000 BTUs. There's nowhere listed in the example that there's any air exhausting appliance in the house. So we're going to use the max column with a capacity of 96,000 BTUs. And we come on up here to the top. That tells us that we're going to have a 4-inch vent in that particular example. I'm going to continue on with a whole bunch of them here, so don't feel like you got cheated. You can see in this case, we got a 22-foot vent height on this particular scenario. So again, we've got B vent all the way, or double wall vent and double wall vent connector all the way from one end to the other of this. It's 38,000 BTU natural draft water heater with a 22-foot vent height. So again, the table we're going to use is going to be C1 because we only have one appliance, so it's B vent all the way. So we've got C1, and as we indicated, we had a 22-foot vent height, we had a 0 lateral, and again, natural draft. You could see that we had 61 and 55 at that point. Now, keep in mind that the draft hood on that particular water heater, I'm going to tell you, is a 4-inch draft hood that is equipped with a water heater. We go back to one of the general venting requirements. It will say we cannot put a 3-inch vent on a 4-inch draft hood coming off an appliance that's natural draft. So because I'm telling you that the 4-inch draft hood is located on the water heater, we have to go with a minimum of a 4-inch. So a 20-foot vent height, 0-foot lateral, our actual allowables in that case would be 119,000 BTUs for that water heater in the event that we don't have any air exhausting appliances in that space. It'd be 107,000 if we went to the DP column, at which point using a 4-inch vent if we did have air exhausting appliances in that place. And by the looks of things, that looks to be exactly what we've done here. We've got 119,000 BTU capacity, and again, a 4-inch vent for that application that we had. I don't know whether I show that one again. Yes, I do. 51,000 BTUs, we said. You could see 23-foot vent height, a 3-foot lateral, natural draft 51,000. Double wall with a single wall vent connector. Okay, so the first one here, that's a single wall vent connector. So we're moving on to another piece here. Remember, C1 was what we used. We had double wall vent, double wall common vent, and a double wall vent connector. Now we've got a single wall vent connector. You can see the lines here are thinner, meaning that that's a single wall vent connector. Now what you're going to find is the capacity of this venting system isn't as great as the one previous that was B vent all the way, because again, it holds in more heat, which means that that venting system actually works a lot better than this venting system itself. But sometimes we really don't need the venting system to work that extra hard. At that point, we can get away with a venting system that works just fine, like this system does. So in this case, we know we got a 23-foot vent height, a 3-foot lateral, natural draft, 51,000. Keep in mind, no mention on this diagram anywhere does it say anything about air exhausting appliances in the house. So we're going to go on to table C2 and again read the table values up there. Capacity of type B double wall vents with single wall metal vent connectors serving a single category 1 appliance, which is what we had. And again, if you look down the table, you can see now our height's 6, 8, 10, 15. Well, we were at 20, right? So now we're going to the 20-foot vent height. We're looking at lateral at that point. I think we were at the 5-foot lateral. Again, I'm going by memory here. Sometimes I get ahead of myself and I'm not remembering exactly of what I'm after. But we're looking at the 20-foot vent height, obviously. It looks like here we've got the 5-foot lateral. And again, we're running across, I think it was 51,000 BTUs. You can see Nat max, meaning no air exhausting appliances, which is what the question really said to us. We have a capacity of 47,000, so that's not going to work. We're going to come across here to Nat max, which is going to be 94,000 BTUs, which is going to mean we're going to have a 4-inch vent system. Let's see how right we were. Hey, look at that. 20-foot vent height, 5-foot lateral over here to the capacity because we had 51,000 BTUs. It wouldn't fit into a 3-inch system. So we're going to have a capacity here of 94,000 BTUs, which falls under the roof of the 4-inch diameter vent system. So in single appliance applications, we're always going to have what we call the lateral measurement, which is the distance offset from the main vertical section of venting. Now keep in mind, if we got 2 appliances hooked up to that system, how are we going to be able to do this with a lateral, right? Because we're going to have 2 laterals, which one do we use? So what we're going to do is we're going to, with one appliance, we're always going to use this lateral measurement. Whenever we go to 2 or more appliances, we're going to not worry about the lateral measurement. Now we're going to worry about what we call rise. A rise is going to be the distance, if you will, from the entrance of the flue gases into the exhaust system or the vent system. So right where my highlighter is running across there, basically up into that vent system. So between this point right here where my highlighter is sitting right now and where it entered the flue gas system, we're going to measure that distance. And you can see I've given it that value of 1 foot. Over here on the mid-efficiency furnace on the opposite side, that flue product is entering right at the cabinet of the furnace, and the rise there is going to be 3 feet. And again, that's going to be measured to this point right here. The reason it's going to be measured to this point right here is that the flue gas from the mid-efficiency furnace is exclusively coming through this section of vent here. Okay, so this is known as the vent connector furnace up to this point. This is known as the vent connector water heater to this point. Everything from this dot upwards, now because we have the flue gas from 2 or more appliances flowing together, is known as the common vent. Okay, so when we look at that in 2 appliance applications, we're actually going to do 3 different calculations. Over here, because that's only serving 1 appliance, this is all going to be the same size, and we only need to do 1 calculation to figure out our entire vent system size. Over here, we are going to be doing the vent connector water heater. We're going to be doing the vent connector furnace. And finally, we're going to be doing what we call the common vent. So we've got 3 actual sizing exercises that we have to go through in these applications. So again, as I mentioned, you've got the vent connectors, the first one being water heater, the second one being your mid-efficiency furnace, the third one being what we know as the common vent, where the flue gases from both of those appliances are going to run together. So now we go back over and we're going to look again at our scenario. Now we've got 2 appliances. We have 1 of each. We have a mid-efficiency furnace, which is a fan-assisted furnace, and we have a natural draft water heater, 57,000. Now, because we have double wall vent connectors and double wall common vent all the way through this system, we're going to use table C3. So it has 2 appliances. Oh, kitchen and bathroom exhaust fan. So as soon as you see that, that means that we're going to use the DP column. So let me write this down, because you know I'm going to forget, especially this time of night when I'm doing this stuff. I'm going to definitely forget some stuff here. So 31-foot vent height. Find a pen that works. We got a 1-foot vent connector rise for 57 on the water heater, and we got a 3-foot on the mid, and it's 100,000 BTU. Okay. So now what we're going to do is we're going to pick the appropriate table, which, as we mentioned, is going to be table C. Okay. So we're going to use table C3, and I've already slid up past the first section there, which would have obviously the shorter vent heights. Let's slide on to the second page, which has the 25, 30, 35, and 100, or sorry, 25, 30, 50, and 100 foot vent heights. And the vent connector rises of 1, 2, and 3 feet, which are typically what you're going to see for vent connector rise. So we're going to pick the water heater first. We know we have a 31 foot vent height, so I'm going to go to the 30 foot section. I don't know why that isn't working. I'm going to go to the 30 foot section here. The 30 foot section is going to be the vent height we're going to use because we have a vent height of 31 feet. We got a 1 foot vent connector rise to the water heater, so we're going to go from 30 over here to the 1, and we need 57,000 BTUs, and we know we have air exhausting appliances, so we're going to use the DP column. So 4-inch won't work because we only have a capacity of 55,000 BTUs. So we're going to come over here to the 5-inch, and if you look in the 5-inch DP column, we're going to be looking at about 86,000 BTUs of capacity for 5-inch. So 5-inch is going to work for our particular vent system for the water heater. The next thing that we need to calculate is going to be for the mid-efficiency furnace. Again, we're going to go to the 30-foot vent height, but now we have a 3-foot vent connector rise. So we're coming down here to the 3-foot section, and because it is a power vented, or a fan assisted is a better term, a piece of equipment, we're going to come over here and look in the fan min and max column, and you can see our limits here for a 3-inch vent are 22 or 23,000 BTUs up to 66,000. We have 100. So we're going to come on over here to the second column, if you will, for fan assisted, which is going to be a minimum of 34,000, a maximum of 123,000. So 4-inch is going to be the vent connector size of choice for that actual piece of equipment. So here we have listed everything that we've kind of talked about so far. Double wall vent connector, double wall vent connectors, common vents and vent connectors serving 2 appliances. We said the house has a kitchen and bathroom exhaust fans, which put us in DP. So we've got the 31-foot vent height, the natural draft water heater, the 1-foot rise, the double wall vent connector at 57,000 BTUs per hour. So that was the 5-inch vent connector size for the water heater. Okay. And again, I'm hopeful. Why this thing won't work as far as my highlighter is concerned. But anyway, all right, so the vent connector for the water heater is going to be 5-inch. The mid-efficiency furnace, we said, is going to be 4-inch. So we figured out the vent connector for the water heater. We figured out the vent connector size for the mid-efficiency furnace. The only thing we have left now is going to be the common vent. And the common vent, what we're going to do is we're going to total the BTUs from those 2 appliances. So we know we've got a 100,000 BTU furnace. We know we've got a 57,000 BTU water heater. And we know we've got a 31-foot vent height. So what we're going to do now is we're going to move to the next portion of this example. So now that we have the vent connectors both calculated for this system, we want to keep flipping through table C3. Table C3 and C4 are going to have a lot more tables in them than C1 and C2. Because C1 and C2, you did one calculation and it did the whole vent system. As we mentioned a little earlier, C3 and C4, we're going to be doing the vent connector for one appliance, we're going to be doing the vent connector for the other appliance, and finally we're going to do the common vent. So we actually have 3 mathematical calculations to do in these situations. So we're on the common vent table, and it's listed right up on the upper edge of the table that you'll see as you're flipping through your tables. So this one's for table C3, and you can see again that we've got our vent height listed down the left-hand side of the column. Now there are 5 choices we have in each diameter of common vent, and I'll talk a bit about those. But first of all, we're going to pick the appropriate number for the example that we had. Again, because we're 31 feet, we want to go basically to 30 feet of vent height, right? The shorter vent height is going to be our worst case scenario. So I'm going to the 30-foot line, and the 30-foot line, I know I've got 150,000 BTUs of appliance input. So the first column you're going to see, let's go back up toward the top, and the heading that says right beside vent height, you'll see fan plus fan. That means if we have two fan-assisted appliances, so two mid-efficiency furnaces, for instance, that we're sharing this common vent, that number would give you the capacity of those two fan-assisted appliances. The next one says a fan-assisted appliance plus a natural draft appliance. Well, again, you pick the appropriate vent height, and that's going to tell you the capacity. So if we have a 30-foot vent height, and we pick the fan plus natural, you could see that it looks like we have 153,000 BTUs. Sorry, nope, my bad. 138,000 BTUs capacity at the 30-foot vent height. The next one says DP. In other words, if we have any air exhausting appliances, which is what we have, and we actually have a fan assist and a natural draft. So the third column or the middle column is the one that we're going to use. And when we go down to 30 feet, you can actually see your capacity there. It's going to be, it looks like 128,000 BTUs for a 4-inch common vent. Well, that's not going to work because we get 157,000. So we're going to go to the 5-inch column. But again, we're going to go to the DP F plus N, which is the middle of the 5 columns. Again, 30-foot vent height. And you could see my vent capacity now is 195,000 BTUs. Well, that fits perfectly, or will easily exceed what we have in 157,000 BTUs. So 5-inch is going to be the diameter of the B vent common vent in that application. There's also a legend down here that talks about, fan plus fan is two fan assist appliances. A fan plus nat means a fan assist and a natural draft without depressurization or any air exhausting appliances. DPF plus N, of course, in a house with exhausting appliances. Nat plus nat, again, in two natural draft appliances, a standard efficiency water heater and a standard efficiency furnace in a house without air exhausting appliances. And then finally, depressurized N plus N, two natural draft appliances in a house with air exhausting appliances, is what these columns actually stand for. So you can see here on this diagram, we now have basically gone ahead and picked out a 5-inch vent connector for our natural draft water heater. We have a 4-inch vent connector for our mid-efficiency furnace, and we have a 5-inch common vent that goes from the point where those two flue gas exhaust from both appliances flow together to the outlet or outside of the house is going to be known as the common vent. Again, that'll be 5-inch. The next example that we have here is, again, going to be another vent example. Again, a lot of the same diagrams, but different values on that diagram and different materials. So you can see in this example, I have a double wall vent connector, a double wall common vent with single wall vent connectors, I mean to say. You can see that my vent height there, it looks like 16-foot vent height. We've got a 1-foot rise on the 45,000 BTU water heater, and our furnace has a 2-foot rise. It's a mid-efficiency, so fan assisted, again with a single wall vent connector at 85,000. Okay. So again, just to make sure, we've got 16-foot vent height. Water heater is a 1-foot with 45. And then we've got 85 with a 2 on the furnace. So if I don't write it down, I'll be wondering what the heck I'm doing here. So next, I'm going to go ahead and pick the appropriate table. In this case, it's going to be C4 because we have a double wall B vent, common vent with single wall vent connectors, or C vent connectors for these two appliances. So we're going to pick the appropriate vent height, which again, we're 16 feet, so we're going to 15. We're going to do the water heater first, which is a 1-foot vent connector rise. 45,000 BTUs. Nowhere did it mention that we have any air exhausting appliances. So we could get away with the NAT max column at 52,000. Our equipment is 45,000 BTUs, so we shouldn't have any issue there with that. So it looks like we're going to go 4-inch single wall vent connector for our water heater. For our furnace, again, 16-foot vent height, 2-foot vent connector rise. We want the min and the max to be in between, or basically encompass 85,000 BTUs. Well, you can see we're in between 83 and 94,000 BTUs, means we have a 4-inch vent connector. Now, hopefully you realize by reading this, and you might not even clue in at this point, but one thing that is good to realize is we got a very narrow band of what we can put in that fan assisted column, right? So in that application, we have to have a furnace that's between 83,000 and 94,000 BTUs. Keep in mind, you might not have a furnace that's 83 to 94. Maybe the company's furnace that you're putting in only makes an 80 and 100. They don't make an 85, right? So what could you do? Well, I've had some students that will say, well, you can adjust the height or the rise of the vent connector, which is true. You can do that. Sometimes you can, sometimes you can't. So in that event that we have something that's very narrow like that, we're going to talk a little bit more about what to do in this example. Remembering that our old friend B vent or double wall vent connectors are way better at getting the heat or having the vent system work. So really what you'll find is if we went and turned that single wall vent connector into a double wall vent connector, we would actually be able then to use B vent in place of C vent, which gives us a much, much, much wider range of the amount of BTUs that can go into a vent system like this. So if we had an 80,000 BTU furnace or a 100,000 BTU furnace, it would actually fit if this thing was B vented. So we as technicians have to know, okay, it doesn't fit within the table values or parameters of what single wall venter do. We actually have to go back and recalculate this using table C3 with a double wall vent connector. But we'll talk a little bit further about that coming up. So 16-foot vent height, double wall common vent, the natural draft water heater with a 1-foot rise. So even though it's showing here a single wall vent connector, we look in the tables and we see that it really doesn't fit when it comes to the mid efficiency if it was a different application. So what we've got here is the natural draft water heater, 1-foot rise, single wall vent connector on a 45,000 BTU, which is what we said. And we said that was 4-inch. We were good with that. The furnace, we said, did fit with a 4-inch there as well, as far as the vent connector is concerned. So the only thing we really have left is going to be to combine those BTUs, which is 130,000. And again, because it doesn't say anywhere in the question that we have any air exhausting appliances, we can use the non-DP column. So what we have here is an F plus N application. So again, what we're trying to show, I'm kind of going backwards a little bit here, is that 15-foot vent height as indicated, 1-foot vent connector rise to the water heater, had a capacity of 52,000, which was 4-inch. And again, I don't know why I repeated this, but anyway, in this case, still 15 foot. We had a 2-foot vent connector rise for the fan assist, and as we indicated, 4-inch worked because we had an 85,000 BTU input for that water heater, right? And that's basically what we're indicating here. The next thing we're going to figure out here is going to be your common vent sizing. And we go to the appropriate common vent table. We have 16 foot, so we're going to the 15-foot vent height. We're going to use not DP, it's going to be fan plus NAT. So it's going to be the second column over. And we have a combination there of 130,000 BTUs at 16 or 15 feet. So you can see fan plus NAT. Our first column of 4-inch is only going to give us, looks like 108,000 BTUs. We move across to the 5-inch. It looks like we've got, what, 159,000? And what have we got there? Yep, we're good with that, 159,000. So 5-inch is going to be good for our common vent in that application, which is what it should show here. Yep, 15-foot vent height, 159,000 capacity, which means we're going to have a 5-inch common vent in that case. So when we look at that point, that's where we would look and see, okay, we've got a 4-inch vent connector water heater, we got a 4-inch vent connector on the furnace, and then we had a 5-inch common vent. Usually the common vent, in fact, it's extremely rare that the common vent is going to be smaller than either one of the two branches. It's always going to be at least one of the sizes, the smaller branch anyway, usually the larger branch, or a step up again in size. In this scenario, I'm talking just about what I just did in the last one. So now we're going to change, everything else is the same, but we're going to change now the mid efficiency to a 75. And I already let the cat out of the bag because really, again, we're going to figure everything out the same way. You're going to go water heater. We know we had 16 feet. Our water heater at a 1-foot vent rise, 45,000 BTUs. And we came across here and we said there was nothing in there in the way of air exhausting appliances. So we could go to 52,000 BTUs, which gives us a 4-inch vent connector. And again, you can see I've circled how I got that on the sheet. The next thing we're going to do is we're going to go and do the mid-efficiency furnace, 85,000. Well, now it's 75. So 15-foot vent height, 3-foot vent connector rise. And you can see now we don't fit in between on that 3-foot vent connector rise, or sorry, 2-foot vent connector rise. I'm a liar here. 83 to 94. Well, we're at 75, so we're screwed. So again, what we're going to do, because it won't fit in table C4, we're going to change that vent connector. No one's going to tell you that you have to do this. You just have to make it fit within these table parameters. So the next thing we're going to do is we're going to go back to C3 because we got 75,000 BTU capacity, and that won't work on table C4. So we're going to go back to C3 now. Table C3, you can see I've got circled up here at the top, and again, we're going to choose 16-foot vent height, so 15, 2-foot vent connector rise. And as we come over here to the fan assist column, you're going to find that we have a much wider range of BTUs that can go into that application. Now we can go anywhere from 35,000 to 96,000 BTUs, which encompasses the 75,000 that we just talked about. So you as a technician have to know that you can't get away with single wall or C vent connector for that particular appliance. You have to go to B vent or double wall. The water heater can still stay as a single wall appliance, or single wall vent connector, sorry. But the furnace has to go double wall. So once we've done that, we will typically, if I remember correctly, and I'm going by memory here, in fact, I'm going to cheat and go to the next sheet. When we go to figure out our common vent, we're going back to table C4. So we go back to table C4, and again, we've got 16 feet. Again, we've got, now we have 75 and 45, which is going to be 120,000 BTUs at the 15-foot vent height. Again, we're going to be fan plus nat, and it looks like we're still looking at 5-inch that we're going to utilize for our common vent size. 159,000 BTUs, 5 inches is going to be our common vent size for that application. I think what I'm going to do is I'm going to shut that down there for now, because we're going to start talking then about doing some other types of applications. So I'll continue on this in the near future.